Hello, welcome to the Inter-Airport Connect. It's today the 21st, the second day of the connected event. Welcome to the audience, welcome to our speakers. I am Jan Ray, your host, your moderator for today. I'm Vice President at GATE, and I'm in my normal job with Airbus in the business development. So I have the honor today to guide you through the presentation and to the impulse discussion that we have today. We have great speakers today on board. Just a first announcement to the audience, you have the possibility to put questions. See up left or right of your screen, you can put questions that we will then end up in putting it later to our discussions. From the setup, we'll now have 30 minutes introduction and impulses from our speakers. So enjoy the presentations, and the last half of the presentation, 30 minutes we have in total, we will have the opportunity to put questions and have a great discussion together. So as you know, the Inter-Airport Connect is ahead of the live show that we have in November. So this is a good warm-up for all of us to get to great innovation, product, system, and services, and also to all the things that we will that we want to have in also this critical times, things that get us into the future. Today's impulse discussion that we are hosting is the connected airport, how digital twins can optimize asset operations. And I just give a little overview about our speakers. Today we have in the panel Ilka May. She's CEO of LogLab Consulting. And I just read through her great company side, and the most striking thing was we create digital twins. So I think this is the great and the best thing that we need today. So nothing more to say here. We have Michael Mowinsky from T-Systems International. He's Director Airports and Air Traffic Management. He is a guy from our industry since 30 years with Fraport, so he knows everything from ground handling and above. And our third speaker, Christian Hörmann, he's account manager of Esri Deutschland in the field of transport, telecommunication, and utility. He's our expert today in geographic information systems. Christian has 20 years of experience in mapping and applying geospatial analysis using geographic information systems. So this is a long but very impressive record. So we are ready to go, and we hope you have a great presentation, and we have great discussions. I now give over to Ilka to our first presentation of today, and yeah, it's your show, Ilka. Let's go.
Thanks, Jan. Hello, everybody, from my side as well. So I'm the CEO of LogLab, as Jan already introduced me, and I have the honor to give this little burst presentation on behalf of T-Systems, of Movi and LogLab. And I'm sure you've heard of T-Systems. You might have not heard of LogLab before. But I hope that this presentation will show you the synergies between a big tech company standing for the power of IoT, of 5G, of cloud, of all sorts of technology, and of LogLab. And as Jan said, we create digital twins. And this is the title of this presentation. I want to talk about the power of combining the two, and what this will give you in general, but also in particular, obviously, for airport operations. So we'll start with a little definition of what we're talking about here, the digital twin, because there's many people understand different things. So in our understanding, a digital twin is not only an intelligent digital representation of an object, with a certain data structure, as you can see at the top images here. But in our understanding, it also has a spatial component. So it's a a proper spatial and geometrical representation of an asset or an object. And it has a data structure, an object data structure in the background. And that unleashes the full potential of a digital twin, which is when you start connecting data through the twin to the objects. And when you start combining the two so that they start to communicate in a way so that they create a bi-directional conversation or data exchange. And then if you start adding multiple digital twins, let's say in a production line, for example, some people call that the digital thread. And there is a big potential in doing that. Industry 4.0 uses that a lot. And as I said, we will also demonstrate you the benefit and the power of that when using for airports. So the next image gives you already an idea of what the spatial twin provides as additional information and context. On the left-hand side, you see a dashboard, typical dashboard of a building management system, or could be a facility management system. You see sensor names and room names, etc. And you see that in one of the rooms, the temperature has gone up. But you don't get a lot of context of what is around, what does it mean, what do I need to do now? Do I need to evacuate the room or the building, or what else do I need to do? When you look at the right-hand side, it gives you a lot more context, because the same information is now provided in the proper 3D environment, and you can see what is in the room, next door. You can virtually in the digital model now walk to the room next door and get a better overview of what is around. And now what you see here on this slide is a few more examples, and they all show you real-world examples of digital twins combined with data through Internet of Things or other technology. There's always the data structure in the virtual model connected to other data and other systems. So on the top left, that is the headquarters of T-Systems in Berlin, where we've connected the building management system to the virtual model. And you can click on a component or an object in the model, and that gives you a jumping point to other data that sits in other systems. That could be a commercial system, your contractual system, your facility management system. Doesn't matter what it is, it could be just stored anywhere. It's just a link to the data. The bottom left is the same building. That's where we connected a lamp in the virtual model with an IoT lamp in the building in Berlin. And you can see, you can now start switching the light on and off. You can dim it and you can start manipulating it. And you see the latency in the little video where the lamp reacts to what we do in the virtual model. And the both examples on the right-hand side are from a hydropower plant. And that shows you the bidirectional system I talked about earlier. So you will receive data, for example, in the top example, an error message, a sensor has gone off, and the camera in the virtual model takes us straight to the point where the error has occurred and gives us the context I talked about earlier. And the bottom example is where we can put data through the virtual model into the system. For example, we can report a fault or an error, and the facility management team will receive the report and the place mark and know exactly where the error has occurred. So that's just a few examples from real life projects. And now let's talk a little bit more about the potential, but also about some of the blockers in the industry. So the potential, if we believe market research from companies like Gartner and others, the potential is enormous. It's vast. And especially in Industry 4.0 and in operations, maintenance, and providing services, just to name a few of the numbers, as you see here on the slide, the projected market size in US dollars by 2026 is $48.2 billion, for example. And I found it very interesting to see also where they see the growth and the scalability of this business, and that lies in managed services and also in marketplaces. And there are many other studies just highlighting where the benefits are. But if this is also great and fantastic, and we all believe in these benefits, we should ask ourselves, why is not everyone using digital twins already and IoT, etc.? So there are certainly a few challenges there. And this is from a study that was conducted by engineering.com, but also that reflects very much the feedback that we get from our clients and customers. So first of all, there is very often still a lack of the understanding of all these benefits and of a valid business case that clearly shows investment and return on invest. And in the lack of that business case, very often we see the lack of management support, and leadership will not approve investments, etc., and go down this route. If they do, and if they decide, yes, there is potential for us, we have a business case, and very often people are not clear where to start with. They haven't got the vision, they haven't got a clear roadmap, and they don't know where to start. An often observed problem, and we can talk about that later in the panel, we can pick that up, is that many people and many organizations are organized in silos. So they have their own responsibility, they have their budgets, they have their reporting lines, and it's all vertical. And the digital twin technology is a horizontal technology, it integrates, but very often there is no business, there's no budget for integration, too much silos. It's also that our information, our data is organized in silos and in systems. And again, there is very little flow of information across these silos. So we see a lot of duplication in data, but not much integration. A lot of people also see some financial hurdles and some reluctance to make initial investments. There's often also a lack of expertise in implementing new solutions. And some people report that they're not able to find the right solution or the right software for their environment. So that's a lot of things you might recognize your own organization or yourself and find yourself in that. And as I said, I would be happy to discuss that later in the panel. So between T-Systems and LogLab, how do we respond to these challenges? What do we do about these? And between us, we've created an end-to-end solution. And we think it's important that people understand the challenges and how to respond to them. So for the business case problem, a very good solution is that you start with pilot projects and you start to get some quick wins and tangible benefits that you can present to your leadership, and that you get their buy-in. For the siloed systems, we strongly believe, and we see that these object-based digital twins we talk about, they are a perfect start for proper integration, and you don't have to do it all at once. It can be a stepped or a staged approach where you integrate more and more systems and data after the other. The financial hurdles are important to understand your requirements and understand what drives cost, and we can talk about that later, because there are ways how you can bring down the initial investment and the financial hurdles. Technical hurdles and data security is important. So T-Systems certainly stands for a very secure hosting and operation and maintenance of your digital data. And the lack of expertise, well, we're here to help. So often when people are convinced and they would like to start, they don't know where, as I said, and the customer journey is important. And we always try to convince people that they should understand what is they're trying to do, understand what problem they're trying to solve, which areas they're trying to improve. And that brings you to your selected use cases. And ideally, your solution should tick as many use cases as possible so that you get your valid business case. The use case determines the quality of the digital twin and what it is you need. And the quality in terms of data accuracy, position accuracy, granularity, etc., that should define your data input. A lot of people seem to think that a digital twin of an existing asset always needs to start with laser scans and laser point clouds. It's not necessarily the case. It always depends on your required quality. And that's one of the areas where it can massively reduce cost, as we can show you in a second. And then you get through to your 3D model and then to your integration questions. So bringing costs down, one of the specialities and USPs of LogLab is we've developed a method where we can create an object-based digital twin of an existing asset from videos, action camera videos. Such a device costs 350 euros. And in most areas and for most use cases or many use cases, that creates exactly the quality that is sufficient. That's great. And you can see in this example here, there's the video on the left-hand side. We create a video grammetric point cloud from the video in a first step, and then we create the object-based digital twin. And we use artificial intelligence and semi-automated processes and algorithms, which help us to do that in a semi-automated way. And again, that is a lever into cost reduction. So that's not all manual modeling work. So talking about costs, on the left-hand side, you see this beautiful digital twin of the Berlin railway station, and the data capturing time that we needed to do this model, to gather all the input data for this model, was 3 hours. So the cost is about 100 euros. So all you need as a person walking down all the publicly accessible areas with the video camera, and that's all you need. And that takes about 3 hours. It's a big railway station. Could be an airport, just probably a bit similar. On the right-hand side, then you see again a glimpse into the production process. Video on the left-hand side, then this funny-looking point cloud, which doesn't look very nice, but it's an interim step, which then gets us to the digital twin. In this case, this is a train station. So that gives us the model, the object-based model. But what we need then to integrate and to connect and to get the real value from the digital twin is the other technology, and that's what T-Systems stands for. It's the IoT, is the cloud, and it's the 5G and edge. So that brings the model to life. And with the right actors and sensors, you can then act in both directions, as you saw earlier in these examples. Cloud, clients and companies need to establish which processes need to stay on premise and what they can move into a public cloud or into a maybe private cloud. And just one word about data security. Data security is something you should and need to think about from the start. It's not just something you bolt on at the end. That should be an integrated part of your thinking and your whole IT setup. Well, and then we have also the 5G and edge, which is then for certain use cases where it takes away the latency and enables more and more use cases that we can then use the digital twin for. And now coming to the end, thinking about airports in particular. So where have you got your assets? What assets do you operate? How do they communicate? How do they integrate? And think about what the spatial context would give you as an add-on, understanding where things are, how much space is there in between, could they be elsewhere, would they fit? Just doing very, very many spatial analysis could really improve how you operate and how you maintain your airport in many different ways. And that's the impulse we wanted to give you for the discussion. I'll now finish with our vision, joint vision between T-Systems and LocLab. We definitely want to go into this blue area that I mentioned earlier, the managed services and the marketplace. So T-Systems and LocLab, we offer individual customer-based projects and digital twin implementations. We combine the technology, the best of technology from both companies, and we're developing further offerings. And this is now the final video. This is the hydropower plant you saw earlier, produced from a few videos only. It's a massive model. And this shows two data integrations. One is a real-time sensor integration through an Apache Kafka server. You see here the location of different sensor data. And if we were connected to the intranet of the operator, we would see the different sensor readings. So this is how it shows it connects sensor and real-time data. And now we can, in the virtual model, walk into the power plant. And because we're in the virtual world, we can just take the shortcut. We can dive straight into the, across along the turbine into the basement. And that's where you will see the second data integration now. And that's the SAP integration. So you can connect to the SAP data of the operator through clicking on the item in the digital twin. And now you see the tree structure of the SAP, but also you see the spatial context, and you can see work orders and other data that sits in SAP. And as I said earlier, you could also now start entering data or trigger a procurement process or do other things which will really help you to reduce time in your processes. Good. Hopefully that gave you enough food for thought and for questions. And happy to hand back to Jan now. Many thanks.
Thank you very much, Ilka and Michael. Since we do not have heard a lot of you, but we'll hear you later. One question, Ilka, I have just right away. You talked about managed services. Could you explain from your point of view what that means in your context?
Yeah, one simple example would be the service of hosting data for the clients. A lot of our clients come back and say, now we've got so many 3D models. Some of them come from a design process. We receive them as 3D models, as BIM models, for example. Other models or point clouds and other data we receive from our surveys and from existing assets, etc. We don't know where to put them. We haven't got the systems. We don't know. And that's one of the managed services that we can offer. We provide a platform which hosts in a secure environment the system, but also then starts connecting other data and then provides certain functionality so that the clients don't need to buy and procure software to do that, but they can just subscribe to a license and have all the functionality they want.
Okay, good. Okay, I think we'll have time later on also to deep dive into this topic. So thank you very much, Ilka, at this point. Christian, now it's your turn. Christian, account manager for Esri Deutschland. Now it's your turn. Just go on. And Christian, we need to have you unmuted, please.
Yes, that's me. It's unmuted. Well, thank you for the introduction before, Jan, and thank you for the opportunity to present today. I hope you can see my screen.
Yeah, perfect. We see everything. Super.
Okay, great. Thanks. And thank you, Ilka, for the great presentation. So, hi, everyone. Hello from Bavaria, Germany. Here at Esri, we work together with some larger airports, and globally, we work with many other airports all around the globe. And today, I'm happy to present how a GIS, a digital twin, can provide benefits to an airport. So I will briefly introduce who is Esri. I will show how airports benefit from geospatial solutions and how the connected airport benefits from a central location data management. I will then give some examples of digital twins and finally finish off with a Q&A and the following panel discussion. So who's Esri? Esri is the global market leader in graphic information software, location intelligence and mapping. And we're basically located all around the world in 67 countries. We provide organizations of every size and industries the tools to get deeper insight from the data to improve operational and business results. And that are industries like the commercial sectors, environmental agencies, governmental agencies of all sizes in general, the transportation, telecom, utility market, but also R&D centers and education institutions, and many airports around the world. We are founded in '69, so some days ago already, and the software is well used by many customers around the world. For those of you who are not familiar with the term GIS or Geographic Information System, I will briefly cover that. GIS provides a process and a framework, not only for creating geographic knowledge, but also for applying it widely. With a GIS, we measure, we visualize, we analyze, plan and design. And finally, it's used to make better decisions based on data and analysis. And a GIS today basically runs on any device, on every system. So it could be a desktop, on your browser and the web, a smartphone, tablet, or integrated in other third-party systems. You can deploy it on your own computer, your own server network, or in the cloud. It's very flexible and scalable. And the interesting thing is what a GIS does, and this becomes very important later when I talk about the digital twins. The data for the twin can come from many sources, in many formats. GIS is able to integrate various data sources and make it available at a central location. That's data like CAD data, it could be real-time sensor feeds, or many other different data. As just mentioned, the GIS interconnects and integrates data, but also people and workflows. And that's very important when it comes into breaking up silos within one organization on the airport. So a GIS builds a base for certainly for data capturing, so like integrating the LiDAR data. We've seen examples just before from Ilka, data from your construction projects like BIM data or other 2D and 3D data. It's about providing dashboards with aggregated information, visualizing the data and for reporting functions, but also for analysis and predictions. You can take advantage of artificial intelligence or machine learning algorithms, basically to analyze, predict, or simulate future conditions. For example, for predictive maintenance. Last but not least, a very important aspect, GIS enhances sharing and collaboration within an organization. So working together not only with one team or within one department, more within the whole organization. And once the data is readable or available at a central location, ideally as a web service, you can reuse the data in various applications. Applications like desktops on mobile devices, or you integrate it with your ERP or asset management system. You can publish the data to the public or create dashboards. Dashboards like the Johns Hopkins COVID-19 dashboard. I guess most of you know that, for example. But so what are the benefits for an airport when they use a GIS widely, and how does a digital twin support those workflows? Well, as we've all heard before, it's a difficult time for airports all around the globe. So sustainability, resource efficiency, cost effectiveness. Yes?
Christian, sorry to interrupt. One question I mentioned, I wonder, you have a presentation, right, that you are just seeing, huh? Yeah, we cannot see it. It's not shown. We just see you, what is nice, and your background, but we do not see the presentation. And I was just wondering.
Yes, well, hold on.
Probably it's the way to share it.
That's why I was asking before if you can see my screen.
Yeah, and definitely we see you.
Okay, hold on. I share the screen again. Start the presentation again. Can you see something now?
No, not yet. Not yet.
Okay, because here it says presentation started.
Now we see it. Now it's there. Perfect.
Okay, so it perfectly worked when we tested it.
Okay, cool. So let's start over.
Yeah, so I have enough slides prepared, but maybe we can cover some of that again after in the panel discussion. So I was stopping here at GIS for airports and how a digital twin can support those workflows. And I was stopping at the difficult times at the moment, and where it becomes sustainability, resource efficiency, and cost effectiveness even more important than ever before. So we believe that there are three main key business enablers for GIS in airports, and these apply not only these days. So it's basically improving operational efficiency, so optimizing what you already have. It's providing insights into activities to be used by different departments. This becomes possible when you deploy a GIS centrally and when every department becomes access to the data and the apps. And last but not least, maximizing non-aeronautical revenue. So there are many aspects and ways to reach that goal. But today I want to focus on the digital twin and how that supports an airport. So what's the vision for a smart airport? A smart airport will be fully connected to all stakeholders. It will operate in real time in response to operational needs from airlines or other partners, especially traveler needs and expectations. And a smart airport will give access to authoritative content to inform business decisions. So smart airports are certainly safe and secure. So knowing where critical assets are and how to quickly access or to deploy those assets. They are well run, creating more efficiencies, such as enabling with operations and maintenance with mapping tools, for example. They're sustainable and environmentally focused, so reducing carbon footprint or the noise pollution. They're certainly compliant to regulations, and they're customer focused. There are new times and there's new technology around. And these technology trends here are disrupting traditional airport business models and creating new challenges, but also creating new opportunities and innovation. So how do they relate to GIS? Most of the data have a location information or are related to a location. Like every sensor, every device, every asset has a location. Whatever happens at an airport, there's a location attached, and you can use it to better understand how things relate, to find patterns, or to see how things interact with each other. Finally, to make better decisions. So GIS is a key technology in enabling the smarter airport vision. GIS provides powerful data management, visualization, and analytical tools can be leveraged to achieve higher levels of performance and certainly safety and security. So GIS can be a very good foundation for digital twin. And we already heard what a digital twin is. And again, there's another definition, and there are many definitions around. And how GIS relates to it, we'll cover that. Maybe the most important word here is integrates. GIS-based digital twin can provide a central platform for integrating data and making it available for many use cases and many users. So a digital twin can also be seen as a central data hub, or a single source of truth, or just a central location for location data, and therefore a very good starting point for many other data-driven workflows. So it can harvest various data at an airport, can make it available for many other workflows. There are workflows like operation, passenger experience, property management, you name it. So before I come to an end, let's have a look at some examples and to get a feeling of what a digital twin in action can look like. The examples that run based on web services, so they're easily to integrate, easy to use on any device, as I mentioned before, browser, mobile device, or wherever. I guess you all know Schiphol Airport, one of the busiest airports. And on this publication shown here, you can find a great use case of a digital twin. Schiphol here in that use case also combined the digital twin with real-time data, like the actual status of lifts, escalators, travelators, and the actual location of airplanes and vehicles on the airside. Here, the digital twin also provides the opportunity to run simulations, for example, for predictive maintenance. So you can think of it as a common operational picture. Maybe one more example from the other side of the Atlantic, from Houston. You see how you basically can fly through the airport into a new terminal. It gives managers, technicians, contractors, or other stakeholders a detailed and seamless view of the current status of the construction. And remember, that's very important, these 3D visualizations are all based on intelligent data that you can analyze, query, and not only visualize. Even that's a huge benefit. So there are many other examples and use cases, but I will stop here. And thank you very much. I hope you got an impression of how an airport can benefit from a digital twin. And yeah, I hope as a result of this very short introduction that you now have a little bit better understanding, and maybe you've seen an interesting use case or example. And yeah, thank you. And back to you, Jan.
Thank you very much, Christian. That was very interesting, great use cases. I just have my first question for you on this one. What do you think is missing for airports to immediately start into the world of digital twins? As it seems to me, it's even something that needs to be more communicated, what it really is. What is the point here?
Yeah, well, there are more aspects to it. It's certainly the data and the software you need, and well, usually a GIS has a GIS system, but maybe it's not at a central location, or it's not ready to deploy it for the whole airport. Sometimes it's only used within one department. So that's definitely one aspect. But the other aspect, and Ilka highlighted it as well, you need management support, and you need a digital thinking. Doing things and projects in a more digital way, that definitely helps to start a digital twin project.
Okay, perfect. I think I also want to put this question to our panelists. How about you? What do you think, Michael? Is there other examples from your experience? I think you have a long experience in airport handling with Fraport. From your experience, what may be the showstoppers or the hindering things to start into this world of digital twins from your view? Okay, you are on mute, Michael.
Sorry.
Perfect.
Can you hear me now?
We can hear you. Yes, we can hear you.
I thought I was unmuted, but thinking is something different. Thanks again, Jan, for this question. And let me first thank my colleagues Ilka and Christian for the great presentation, which has shown there are two worlds. The first world is the geographic information system world, where we have a lot of data at the airports already existing. And the second world is to create this digital twin. And I think in answering your question, what is the main hurdle in bringing the digital twin to the airport is to understand what is a real digital twin. And yes, of course, I have thousands of ideas how an airport can use digital twins. As you have seen from technical point of view, it's related to facility management, to look for the predictive maintenance, how is an object living, how's the temperature in the terminal building, for example, how's the temperature of the engine. So these nice things we can already have on some dashboards. But the real advantage is that you can have a walk through your entire airport at the end, or if it's a railway station, but the airport is similar. And what I have in mind is not only to look the facility management within the terminal building, but also on the air side. What can we do on the apron or on the runways? There are a lot of things already existing, and we can combine them and use them in the digital twin to improve the operations. For a small example, you have on the runway, you have metering devices which measures the contamination of the runway surface. You can bring them also into the digital twin and make real-time decisions in your airport operations center to combine this information with other information from the terminal, for example. Yeah, and in the presentation of Ilka, she mentioned that one hurdle is also thinking in silos. And if we are in an airport operations center, there are a lot of silos already existing in one room. And with an integrated systems using a digital twin, you can bring them together. So I will stop here for the first time. Maybe I make a hint to the poll question we provided at the beginning of the session of the webinar. Do you agree that the digital twin will improve your airport operation? And we had a result of 60% saying yes, a digital twin will improve the airport operations, and 40% no. And I think we can improve this figure if we explain the sea-level management of the airports. What is the advantage of a digital twin? And maybe this webinar could help to improve this figures. Yeah, thank you, Jan.
Yeah, it's I mean, it's interesting also here to see that immediately everybody's talking about business and money and how much investment there is and where is the sausage, you know. Interesting enough is that a lot of innovations needs to be developed before they can really do money, and we do not have also a clue what kind of advantages we will have in the end. I think this is a pity. It's with every innovation, with everything you start. There's another one also that I want to address to you, Michael. It's about sharing data. We had a pre-talk, and you were also saying that there is already a huge amount of data available today, but it's not used for these kind of applications. And maybe the digital twin isn't that new, but it's a new word. But data is there, and now the twin is to bring everything together. What's your view on that?
You are absolutely right, Jan. Everyone is collecting data since a couple of years, since the storage is becoming cheaper and cheaper. And the systems can collect data. So where T-Systems can help is to integrate through a platform to make use out of the data and use the opportunities of the data. But you have to have the knowledge to interpret the data, the information, and create information out of it and provide it to the airport operations. And my personal thinking is here that the digital twin can help to make it understandable what's about the data itself and how can I use them. And if you see the digital twin, if you have a walkthrough as Ilka has shown, or Christian in his slide, you get an impression what's really going on if you're not really on site and standing before. For example, if you find debris on the apron or on the runway, you can use a digital twin to see the history, which aircraft has passed this taxiway segment or this runway segment, to identify who could be the possible loser of this debris on the airfield. So it's just a simple case, but it's a safety-related case, and then you can reach out for the certain aircraft to say, oh, you have lost your wheel, for example. Yeah. So this is one of the exactly. You have to show it. Yeah.
Yeah, exactly. I mean, this is in a direct consideration with the Concorde event in Paris.
For example, yes.
So this shows how this could be a big thing for security enhancement. Ilka, I have another question here, also from the audience. I collected them, and here are two questions from our audience. Very good points that are, I think, very related, and they are directly related to your presentation. The first question and the second in together is how about the baggage handling systems, bigger assets than the movable ones? How can you deal with these in the digital twin? And related to this, how much effort is there to digitalize them, to have this 3-point cloud application, to put it into a final 3D model? How much effort is that?
It depends on the size of the baggage handling system, as always. Okay, the integration is not that hard. I think people think it's harder than it actually is. The example that I showed you, especially with the hydropower plant, for example, we modeled all the turbines and everything that is making the technology of this huge hydropower plant. Compared to that, a baggage handling system might be complex, but to be honest, relatively simple. When you think of the costs and the effort of creating such a spatial representation of an asset, you should always think of how complex is it, and what drives the costs is how many repetitive objects are there and how many individual objects. And the interesting thing is that the more technical an asset is, the more repetitive objects we normally have, because there might be many, but all the screws and nuts and bolts, they're repetitive objects, which means you model them once, and then you can train the algorithms to detect them in this point cloud that I showed you earlier, and they will be very, very effective in recognizing them and putting them in the right place. So you can increase the degree of automation in producing the digital twins, especially of technical assets. And that's the beauty of that approach when you use AI in that method. And then once you have your representation, and that probably you wouldn't need an extremely high position accuracy. It doesn't matter whether it's a millimeter here or off by a centimeter. What you would need is then the connection to the data that tells you, is it working? Is it functional? Has it got problems? Is the energy consumption stable, etc.? Or is it showing any anomalies in the data, which you can then again visualize through your representation?
Okay.
I hope that answers the question.
Yeah, and I think this might be also a good opportunity for Christian. I think, Christian, you are also in this, you have a view on this, right?
Yeah, right. Well, there is lots of data at an airport, and but data needs to become accessible, and data needs to become information. You need the right app for the right audience. A map is simple to understand, even if you're not an expert with any system. And with a map, for example, or a digital twin, you are able to present the data in a 3D visualization. So you basically see the reality, and our reality is a 3D. So it's much easier to understand it in 3D. And there's so many data hidden in expert systems that are so valuable to many others, but they are hidden in an expert system. They're not accessible to the wide audience. And this is definitely where digital twin can help a lot.
Right, right. So we are now facing our last 10 minutes of our exchange. I want to drive our discussion into the future, on more to a master vision of what we want to do in the end. When I see all these developments, immediately I have this master screen, this dashboard, this guy that is driving a whole airport from a table with a one only computer and screen. Is that the vision that's also behind, or the opportunity behind the digital twin to reach this goal? Michael, may I ask you this one?
Yes, of course. I would like to give you an answer because I have something in mind. Yes, of course. I think digital twin can enable to think different. For example, also Fraport, my former employer, has multiple airports in the operation. For example, 14 Greek airports. And I think a digital twin would enable you to operate the different airports from one side. Today, you are always at an airport on site to steer the operations locally. A digital twin can, to some extent, not the whole, maybe in 50 or 40 years, can enable to reallocate the operations for different entities into one location, and this can save, of course, a huge amount of cost. But here again, what we need, and Christian is totally right in mentioning it. There are a lot of systems existing with hidden data or not expert systems, which collecting data, and we have to bring them together into one, let's say, feed and make use of it.
And Ilka, is this also what you have in mind when you think about your company and how you can support all these kind of different activities? Is this your vision too, or do you have other ideas?
Yeah, our vision is we support our clients. Our clients have their domain knowledge. I don't know how to operate an airport, but they do. That's what they're good at. What we know is we understand data, especially 3D data, and we understand interfaces, and we understand data integration. And we can offer that knowledge to our clients for them to do a better job and become better at doing their own job. And one example there is, we talked about the silos of data and what is holding us back. And we often see it's too much data. Most of our clients, especially clients who operate large portfolio of assets or big assets, they don't even know what data they've got. And even if they do know, they don't always know the quality of that data and if they can rely on it. So is it comprehensive? Is it up to date? Is it accurate, etc.? And helping them to gain a better picture through better data of the condition of the asset, of what's going on site, whether it's real time or whether it's static data. That is really our vision, and that's what I mentioned and what I said earlier, the managed service. We need to understand from our client what they are managing, and we can try to help them to manage it better through better data and connectivity and context.
Yes, and as you mentioned that you see it from the customer point of view, Christian, I want to know your view on. Do you think the digital twin can change the business model of providers of equipment at airports so that they may be more part of a service initiative than just selling the product? What's your view on that? Is that an opportunity?
Well, I think as soon as you've got a digital twin available to a wide audience, there are probably business models created that we don't even know of today. And this is being made possible by providing the data to a wider audience. And not only the data, also the information they need at the right time on the right device. And maybe one more answer to your question before, the master vision. I think an airport is too complex to combine all the operations on one screen. But with a GIS, and once the data is available at a central location, you can easily create customized apps for the right audience. But it's important to have the data available and to make it available to all sorts of different systems. And that works basically the best it's based on web services.
All right, and then I have another question to this. I mean, Michael, you mentioned that through the digital twin, it's for business models like Fraport is doing, where you manage a lot of airports at one time. How do you see here business benefits if you are able to handle multiple airports through a platform where you can also make them available through a digital twin system?
Yeah, I mentioned already. You can save a lot of costs for maintenance people, for example. If you have some problems at a specific site, for example, on an island, you have to send out a mechanic to investigate what is the problem there. If you have a digital twin, you just can make a digital walkthrough of this site and go to this asset which has a problem and investigate it, and make the right assumptions and deploy then the mechanic to the right place. So this is one very simple example which I have in mind. Yeah, but there might be a lot of other examples which can be found.
Can I add something? Yeah, can I add something to what Michael just said? and then it goes even further, because just imagine, yeah, let's go back to the baggage handling system. So it stops, it has a problem. You send the engineer on site to investigate what the problem is. Now he finds a broken part. Normally he has to now disassemble it, take the broken part back into his, wherever he sits, in his basement or into his room, and then find out what the product number is, and then start the whole procurement process, which will then maybe he has to fill in a form or whatever. And another big organization, our client, German Rail, they've looked into that, and they found how long it takes them until the spare part gets on site and the system is fixed. So now imagine that what Michael just said, you send the engineer with his tablet PC on site to the baggage system, the broken system. He points, because it's all geolocated, he points the iPad or the tablet to the broken system. It loads the virtual model of that system. He clicks on it and it explodes in every individual object. And he just clicks on the broken part, and that immediately triggers the procurement process in the commercial system. Someone approves it there. And then it gets sent on site within half an hour, let's say, or 20 minutes or so, and you can fix it immediately. And you reduce the time where the bloody handling system has to stop, probably by 80% or so. And that's the value, and that's a real tangible example which already works. It functions, it's operational.
And I think you find a lot of examples of in this situation. Yeah.
Great. So as we are coming to an end, I think that was a very interesting insight to all these different areas. And I think nothing is better than continue this exchange in real in the Inter-Airport Europe that is taking place 9 to 12 November, remember. So I think we had a great setup here to get introduced to all these kind of activities, and also to the audience. If you have more questions and you want to engage, have the Inter-Airport Europe in mind. We are ready there to answer your questions. Also, the GATE Alliance that I'm representing here today, we are there. So we want to drive this innovation, we want to help you here as well. And very happy to have all you here today. It was great. Thanks, Ilka. Thanks, Christian. Thanks, Michael. I think it's a very interesting thing to see in the future, digital twins. We will see them, I'm absolutely convinced. And I'm also interested to see how this will look for aircraft manufacturers, how they will be involved in digital twin systems. So thank you very much for this talk, and have a great day, and other great presentations of today. Have a nice day, and see you later. Thank you. Bye-bye.
Thank you very much.
Thank you.